All right, 88 asks us to compare two different quantities. One is the instantaneous rate of change of this function. So that's simply the derivative. Remember that if you differentiate an integral, that you're going to take this amount and plug it in here. And so I would get sine of x squared. And because it's x squared, I also have a times 2x. So that's my instantaneous rate of change. The average rate of change, I'm sorry, the average rate of change, the AROC, we'll call it, right, is simply f of root pi minus f of 0 all over root pi minus 0. F of root pi is going to be an integral from 0 to pi of sine t dt. And the f of 0 is going to be an integral from 0 to 0 of sine t dt. And I'm going to divide that by root pi. This I can do on my calculator, but I'm also going to do it by hand because it's not too difficult. The antiderivative of sine, I know. Plugging in 0 and pi gives me the opposite of the cosine of pi, so that's the opposite of -1, and then minus the opposite of cosine of 0, which is 1. And that ends up being 1 plus 1, which is 2. This one, since I start and stop at 0, is 0. So in the end, my AROC is 2 over root pi. And my last step is to set this, which is the instantaneous rate of change, equal to that, which is the average rate of change. And this you do need your calculator for. So I type that in as two different functions. The second one is 2 divided by square root of pi. I've got a window, specific window that I've already typed in ahead of time. And this is the graph that I see. The blue graph here is the average rate of change. Excuse me, instantaneous rate of change function, and the red graph is the average rate of change. And it looks like there are two intersection points, so I'm going to say C for 88. All right, our last one is 89 here, so it's telling us that f is an antiderivative of x squared over 1 plus x to the fifth. And then it gives us two different values to compare, so I'm going to do an antiderivative from 1 to 4. And I know that the antiderivative is f, and so if I do f of 4 minus f of 1, that should be equal to this integral. Another way to write that would be that f of 4 is f of 1 plus the integral of its derivative, which would be 1 plus x to the fifth. Right? F of 1 is given as 0, and so really f of 4 is just going to be this integral. You might try some methods on this one, but it turns out that the calculator is your best way to go. So I'm going to go to my Math 9 and type in the integral from 1 to 4 of x squared divided by 1 plus x to the fifth dx. Oops. And see what that gives me. 0.376. Looks like letter D.